Okay, so in this lesson, what we're going to look at is algebraic expressions and variables. So the first thing we want to look at is what is a variable. Now, a variable is a letter used to represent an unknown number. So here we have some examples here. The most common ones are x, y, and z, or a, b, c, and r, s, t. Now, technically, any letter in the alphabet can be used to represent the variables. Once we go from there, we have what we call terms. Now, a term is the product of two or more numbers of variables, but it also can be constants, just numbers themselves. But more generally, they are these type of examples that we see here. 5x, which means 5 times x. Whenever you see a number next to a variable, it's multiplication. 3 times y times z. And then we have here negative 10 times r times s times t and x squared times y cubed. So just remember that whenever you see a number next to a letter or two letters next to a letter, we don't use the dot product or the cross product, what most people use, the x looking multiplication sign. We can just write them right next to each other. Just also make a note that a term can be a constant as well. That means just a number by itself, like 4 or 5. Then we have that an expression is made up. So an expression is when we make up terms together and we add them or subtract them. So it's made up of numbers, variables, and terms. So here we have w plus 3. So we have the term w plus the term 3, and it creates an expression. We have x subtract 2, a term or the variable, subtract a constant, just a number, creates an expression. 3y subtract z is an expression, and so is 4a plus 3b subtract c, as seen in the examples. All right, so what we want to look at a little bit more is the exponents. And what are they? Exponents are just a way to express numbers that have been multiplied by themselves a series of times. So here we have an example. We have 7 to the power of 6. So 7 represents the base. So that's the number that's being multiplied a series of times. So the exponent tells us how many times the number has been multiplied by itself. So what we see here when we have 7 to the power of 6, it literally means 7 times 7 times 7, 6 times. And so instead of writing that out multiple times, we can just say there are 6 sevens being multiplied. So we say 7 to the power of 6. Now you have to make a general note that you do not mix this up with 7 plus 7 plus 7. When you're adding sevens together, that's when you're multiplying. But when you're multiplying a list of numbers, that's when you raise it to a power. So just keep that in mind. So when a quantity is given in this format, we say that it's raised to the nth power. So whatever exponent you see there, you say to that power. So 7 to the power of 6 can be read as 7 raised to the 6th power. And so if I have 5 to the power of 3, that would be 5 to the 3rd power. Right, so now that we have a general understanding of expressions and exponents, what we want to do is try to evaluate them. So sometimes there's confusion on how to evaluate certain powers that involve negatives. So we have two different examples here. Now these two different examples yield two different answers. And this is the most common mistake that students make as we go higher up in math, even in trigonometry and calculus and pre-cal. So if you have your calculator, you can try this out. If you use it with parentheses and without, you're going to get two different answers. So let's try part A. Part A, here we see negative 2 to the 2nd power. Now what that actually means is I'm saying the 2 has the power, not the negative. So it's really saying I'm squaring the 2. And hopefully you remember, when something's raised to a power, that just means multiplying by itself that many times. So since the exponent is 2, then I'm multiplying the positive 2 times, and then I'm putting a negative to it. That's what that means. The 2 only is connected to the base 2, not to the negative. But in part B, what we see is there's parentheses around the negative 2. And so it's saying you're squaring the whole thing with the negative included. So over here, 2 times 2 is 4, and the negative on the outside comes in, and that gives us an answer of negative 4. Whereas on part B, what we have here is negative 2 to the power of 2, and that's going to give us positive 4 because it's saying negative 2 times negative 2. Those two numbers multiplied together gives positive 4. So two completely different answers. Because if this was your bank account, and let's say it represented thousands of dollars, On part B, that's 4,000, and in part A, you owe 4,000. So they're completely different numbers, and so we have to be very careful with that. Now, because of this, when we are evaluating bigger expressions, we need to come up with certain rules that we can observe. And these rules, we call them the order of operations. Now, if you're in Algebra 2, more than likely you've heard of the order of operations before. Now, generally, it's presented as PEMDAS if you've heard it in the acronym form. If you're looking at the textbook, the Algebra 2 textbook, you won't see it with the acronym. Now, part of the reason is that PEMDAS can cause confusions because sometimes people think it has to go in that order and they leave out the left to right part. So what I have here is PEMA. That's so that you remember that it can be an alternation there, an alternative method. So starting with P, we have the parentheses or grouping. So whenever you see parentheses, that represents a group, a quantity. So whenever you're doing order of operations, always start with the quantity first, the grouping. And then we go into E, which is the exponents. And E for exponents means powers and roots. And we're going to go a little bit deeper into roots later. We learned it earlier with square roots, but powers and roots. And so it's whichever one comes first from left to right. Now that concept follows for the rest. M stands for multiplication or division, whichever one comes first from left to right. And so if you have a problem that has multiplying and dividing, then all that matters is which one is written first. If the division is before the multiplication, you do the division first. And that's where some students get mixed up with PEMDAS. They think multiplication always comes before division, but that's not true. When you have multiplication and division together, whichever one comes first from left to right. Same with the powers and the roots. And then the last, addition or subtraction, whichever one comes first from left to right. So if you see subtraction before addition, do the subtraction first and then the addition. You can treat each row kind of like twins. Generally, when you see a set of twins, you just say they're the same age. Even though one of them might be a little older, the general idea that people see is, oh, they're the same age. And so if you were to go by terms of age, you would just say, well, whichever twin comes first can go first. And that's how you treat each row here. Addition or subtraction, whichever one comes first. Multiplication or division, whichever comes first, and so forth. All right, so just remember that as PEMA for the order of operations. All right, so let's try this out. Here we have another example of order of operations. And what we're going to do is evaluate the following expressions using that same order that we just had. So here we see 3 times the quantity, 7 subtract 5 squared, plus 3. Now I often will use the term quantity to signify a group that's inside of parentheses or brackets. All right, so remember the rule. We're going to start off with P, or the grouping. P represents parentheses. So we want to work inside the parentheses first. And so 7 subtract 5 is what we do. And 7 subtract 5 gives us 2. Then we go follow the order of operations. The next thing, if it's no other parentheses, there's nothing else I can do inside the parentheses. So I move to exponents. The exponent I have there is a square. And remember, to square means to multiply that thing by itself that many times. So 2 squared would mean 2 multiplied by 2. And 2 times 2 is 4. Now that we've gone through exponents, the next is multiplication or division. And we see there, whenever we have a number outside parentheses, it also means to multiply. So just keep that in mind. So 3 times 4 would be the first thing. Do not add the 4 and the 3 because that would be a violation of the order of operations. So 3 times 4 gives us 12. And then our last step there is just to add the 12 and the 3. 12 plus 3 is 15. All right, so let's start number 2. And you could go ahead and try this before I do it. Just remember the order of operations. You can write them out in a notebook and constantly refer to them. So on number 2, we're going to do the same thing. Start off with the parentheses. And so inside the parentheses, you see 2 operations. Do you do the addition first or the subtraction? Well, you go from left to right. So you're going to start off with the addition. So 8 plus 5 is going to give us 13. And then once you get 13, you notice you can still work inside the parentheses. So don't go to exponents yet. So 13 subtract 10 is going to give us 3. Now that we've done all what we can inside the parentheses, we can move on to the next step, which is exponents. And so we see the exponent there is a 2. So 3 squared is 9, right? 3 times 3 is 9. And now we can do the last step of 14 subtract 9, and that will give us 5 as our final answer. And so that's how we utilize the order of operations. Okay, let's try our third example of algebraic expressions and models. This one is substitution. Now, substitution is a method that you'll see in geometry and many different fields of mathematics. And so what we're going to do here with substitution, you're just simply going to act just like it's a sports game. Assume for number one, excuse me, where it says evaluate 3x plus 5 when x equals to negative 2. So that means you're going to replace the x. You're going to substitute x with negative 2. You could think of it as x is, let's say, a basketball player, let's say LeBron James, and he's tired and somebody's going to go in for him, let's say Shaquille O'Neal. And so they're going to switch places. They're not going to be right next to each other. That's a common mistake. Some students will put the variable and the number that they're supposed to substitute right next to each other. But you are replacing them. X goes out and negative 2 goes in. And the way that we do it, we use parentheses to help us to know what we substituted into the value of x. So now that we replace x with the negative 2, we see that's multiplication. Whenever a number is outside of parentheses with no operation that's seen, we know it's multiplication. So we say 3 times negative 2 is going to give us negative 6. And then we can do the subtraction as that's last in our order of operations. And so negative 6 subtract 5. Remember, we can use a number line that to assist us if we have any trouble. Another way you could think of it as money. Let's say with negative 6, I owe someone $6. With that subtract 5 means now I owe someone $5 more. How much do I owe them altogether? And if I was to do that, I owe them negative $11. Or I owe them $11 rather. So our answer there would be negative 11. All right, let's try number 2. And once again, you can pause the video and play it when you're ready to see if you could do it by yourself. So remember, we're going to still use the order of operations. And actually, the order of operations will follow you for the rest of your mathematics career. And so you definitely want to master utilizing it, using it all the time. So we're going to evaluate this. And we have two options. We can use one of the properties that we learned about in the previous lesson, the distributive property. We can distribute that in, or we can substitute in and work our way there. I'm going to use the distributive property, as I do want to show you another way it can be done. And sorry, I'm using the distributive property in the next problem. So for this one, we're going to do the substitution. So we're going to substitute y equals to negative 3 right into there. Remember, you're going to replace wherever you see y with negative 3. So put the negative 3 in there. And you can use parentheses to assist you, even though it's already inside parentheses. That way you know for sure what you're doing, especially when you're substituting into a variable that has exponents. And we'll do more of those when we get to like rational functions later on. All right, so we're going to work inside the parentheses first. And I'm going to do two steps in one here. So negative 3 subtract 8. Remember, you can use the number line. Just draw out the number line to assist you. You'll be at negative 3, and then you go 8 units to the left and see where that takes you. So negative 3 subtract 8 is going to give us negative 11. On the other side, remember I said two steps at once I was going to accomplish there. 3 times negative 3 will give us negative 9. Now remember, we also learned in the previous lesson how we can rewrite plus negative 9 to just subtract 9. And so we're using one of those properties there in this step. So now we can multiply, because multiplication is stronger than subtraction. We're going to multiply negative 4 and negative 11 together. And hopefully you remember this, but when you multiply two negatives, they become a positive. So negative 4 times negative 11 will become positive 44. And then we just have 44 subtract 9, which will give us 35. All right, so that's how we do substitution. You can always replay this video if you need it for that part. All right, so in this example, what we're going to do is review the mathematical models. And so a mathematical model is just simply using expressions to represent a real life scenario. And so just like how we had expressions x plus 5, etc., we can use those expressions to represent something in real life. Now, sometimes we can solve it using boxes and diagrams, but in algebra, we use our variables and expressions so that we can assist other people. We can come up with a formula or an equation that can always be used. And it's used a lot in something called Microsoft Excel. Anyway, let's go ahead with this question. It says, and it's very similar to what you see in the textbook. It says, suppose that you had $50 and you were going to buy some movies on Blu-ray for $16 each. Write an expression that will show how much money you will have left after buying N movies. Now that N, remember, is a variable. It represents an unknown. And so we're going to use N just to help us out. So we're going to evaluate the expression when N equals 2 and N equals to 3. All right, so let's first come up with the expression, sorry. And these are 3 steps that can assist you. Very similar to what you'll see in the textbook. First thing is to create a verbal model. Now, a verbal model is just basically coming up with a worded form of what's happening. So if I have $50, that's my total amount. And if I'm going to spend money, well, I'm going to be subtracting. And what am I subtracting? The price of the Blu-ray. So I know it's 15 subtract 16 something, but it determines how many videos I get. So it's going to be my original amount, my $50, subtract the cost of the Blu-ray times the amount of Blu-ray discs that I will get. So if I get 2 Blu-ray discs, it would be like 2 times 16, or 3 times 16, or 4 times 16, and then I'm subtracting it from the original amount. So I come up with a verbal model, a word form that helps me to see exactly what I'm doing. Now, once I do that, I simply write out the expression by labeling each of those verbal models or those verbal statements with either the number or with a variable. So the original amount will be $50. The cost of the Blu-ray 16, and I don't know the number of Blu-ray discs, so I will use N. So 50 is the original amount, 16 the cost of the Blu-ray, N represents the number of Blu-ray disc. Now you can use any variable that you want. You could have used B for Blu-ray, D for disc. We use here N for number, as that's most times the popular variable to use in scenarios like this, and also X. All right, so now the question asks is evaluate the expression when N equals 2 and N equals 3. And so because they actually tell you N, then you use N. So now that we have that, we use what we just learned in example 3 and substitute N equals 2 first, and then do another expression substituting N equals to 3. So if I substitute 2 in there, I have 50 subtract 16 times 2. And remember, 16 times 2, that's going to give 32. You do the multiplication first. And 50 subtract 32 is going to give us an easy answer of 18. All right, so that means my answer would be 18 for my answer from how much money that I would spend, or how much money I have left, sorry. So then the second expression would be 50 subtract 16 times 3. What would happen if I had purchased 3 movies? Well, it would be simply use the order of operations again. 16 times 3 is going to give us 48. Remember, you do multiplication first because of the order of operations. So then subtract 50 subtract 48 would be 2. So if I went there with $3 if I went there and got 3 Blu-ray movies, I would have $2 and change left over. So you can come up with these formulas and you can generate them so you always know what your answer could be.